Thanks everyone for being here. The topic of my talk today is about making CubeSats, which you'll know after the end of this talk, mission capable. So the one thing I want you to really focus on and take away from everything I throw at you today is that humanity, and not just humanity, but specifically the United States, is betting big on 24/7 constant Earth satellite coverage for a whole slew of services and a whole slew of reasons. Some of the traditional ones are things like weather monitoring, GPS, agriculture, remote sensing and imaging of the Earth constantly for data, and also more recently from companies like SpaceX and Amazon, interest in providing global remote internet and cellular service. But you can't escape physics. When you throw something into orbit, especially at a low orbit like many of these satellites exist, around 300 to 400 kilometers, there's still atmosphere, there's still drag, and your satellite will come back to the user in about a year if you don't have propulsion. That's a problem when you look at the projections for what is going to be happening from a launch perspective in the next decade. We're looking at an increase from about 5,000 satellites up there currently to about 57,000 satellites by the end of the decade, forming systems called constellations that provide that 24/7 Earth coverage. Now, from a hardware perspective, things are progressing. Obviously, it means more satellites is more money to launch. When you can scale those satellites down, they become cheaper to launch, and you can launch more frequently. When you look at a satellite, a telecommunications satellite, typically from 2010 from a company like Iridium, for instance, you're going to be putting in the tens to even hundreds of millions of dollars into something the size of about a Volvo or a Ford pickup. In the last few years, companies like SpaceX and Amazon are shrinking those down a bit. They're about the size of a couch now. They still need propulsion, but they're a lot cheaper, and they can fly at those orbits for the same amount of time as their bigger brothers. So why can't we go smaller? We know that there's satellites that exist currently and have flown from universities called CubeSats, about the size of a loaf of bread. They're another order of magnitude smaller than the current ones. They're even cheaper, so why don't we fly those? Well, because they don't have propulsion. And when you throw something up into those orbits without propulsion, like I mentioned, you're still going to come back to the sender after about a year, which just isn't commercially viable when you want to have internet or remote sensing or weather or anything like that. It's basically a subscription model waiting to happen, which I absolutely loathe. So electric propulsion is key to longer satellite orbits on life. What electric propulsion is essentially using electrical energy to accelerate ions for thrust. The trade-off with conventional chemical propulsion is that it's much lower thrust, but it's much more fuel efficient. It's like putting a Prius into these low Earth orbits, and it can sit up there for years. It's really good for orbital station keeping and maintaining a presence in those low orbits. But it's not without its faults. Even though they're very efficient, they still rely on pressure systems that are very old school. You can think of it like a scuba tank that you now need to fit into your loaf of bread somehow. This is the actual scale comparison of a conventional propulsion system with one of these CubeSats. So what we've come up with in the Space Propulsion Lab is an alteration on that physics to utilize an electrospray mechanism as our new source of ion emission for thrust in these scale of satellites without actually having to increase the footprint. You can think of this whole operating system similar to how inkjet cartridges work. We're using an ionic liquid which has both positive and negative ions freely in the liquid that does not evaporate in a vacuum. We focus that up to a really small emission site that's held in a very strong electric field that's strong enough to rip out those ions just like you would from a plasma for thrust. The trade-off being we don't need all that bulky equipment, and we can fit this into a postage stamp size thruster now that's completely contained without any valves, without any tubing, and without any of the fault-tolerant hardware that needs to come along with it. So for a CubeSat propulsion system, you still need some things, and luckily this electrospray works really well with that. It needs multiple electrospray thrusters in parallel so that you can have a neutral beam, just like the bigger brothers propulsion systems. You need it to not be pressurized for scalability. You need very low power because these very small satellites don't have much power. Their solar arrays are very small. You need to be very propellant efficient because, again, you're very small. You can't bring much propellant with you. You basically need all of these things to be solid state, and that's what electrospray offers. So what does that mean to potential users of CubeSats? Well, it means directly an increase in lifetime, which increases the value of your mission and your satellite. Whereas if you're going to put up a CubeSat with no propulsion, you're only going to get about 8 months to a year of lifespan out of that for the cost of about $400,000 to $500,000 per CubeSat. By putting each CubeSat up there for 3 years, there's direct value added in every year that you gain. So we're a small team, but we have some goals. We're starting a company in the Nashville area this year. We want to grow that team with marketing and business membership. And we're working on doing environmental testing of all of the individual subsystems that have both been tested in the lab and in space to make an integrated propulsion system that's optimized for this CubeSat market that we think is going to explode here in the next decade. And we want to develop a flight-ready system in that 3-year time frame. So with your help, we hope to make these CubeSats the new satellite workhorse in these low Earth orbits and go from 50 satellites per launch to about 1,000 satellites per launch. And you can help with introductions to potential aerospace, defense, telecommunications companies, users of satellites, intros to interested co-founders or team members in that business and marketing side, and honestly, just your advice. So feel free to come by our poster at any time, and I'd be happy to talk to you about space stuff. Thanks.